Today we're going to learn how to do and how to identify compositions of transformations. A composition of a transformation is just a fancy way of saying that you're going to do two or more transformations, one right after the other. Just like how famous music composers put notes of music together, you're putting transformations together. We're going to go through all of these different types of transformations and review them. So if you feel pretty confident on each type of transformation, how to perform it and how to identify it, you can go ahead and skip to the next video. In the warm-up questions, we want to know which transformations are rigid or which ones have a congruent pre-image and image. And the ones that stay congruent are the ones that always stay the same size. So that's translations, reflections, and rotations. Dilations change sizes so they won't be congruent. Which transformations make similar figures and they're not congruent? That's the dilations. We just talked about that. And then what does the word prime mean? That means that the shape has been transformed. It's the image of the shape. All right, now we're going to go ahead and review all four types of transformations that we know. Translations are also known as slides. They're kind of the easiest. You just add or subtract to the x coordinate to move left or right, or add or subtract to the y coordinate to move up or down. If you want to do both, then you change both of them. You pick a plus or a minus and then add a number. This way of writing it looks really confusing, so it might help you to just write, oh, this would be like x plus 3, y minus 1. That's going to be the type of thing it's going to look like. And just know that you could change out that plus for a minus and vice versa. Let's look at this translation. Sometimes you'll have to identify that it's a translation before you actually figure out what the rule is. So translations are easiest to identify in that all of the points are in the same spot when you look at the triangle. The L is at the top on both, and P and F are both at the bottom. So that's our translation. The shape really didn't do much. It just looks like you copied and pasted and then you didn't do anything after that. So to find out our rule, make sure you go from the old shape or the non-prime shape to the new shape and pick the same lettered point. So we're going to go from L to L prime, and I go this way and then I go this way. So on my x coordinate, we moved left 4, so that's a minus 4 on my x. And then on y, I moved up, so that's going to be plus. And that's translations. Of course, translations will result in congruent shapes. You might want to write that down because you might have a question that asks you how you know something is congruent. And you say, well, it's a translation. Reflections are also known as flips. You flip an image across a line of symmetry. Here are some common ones that we know. I frequently don't memorize these. If you would like to memorize them, you can, but there are ways to perform the reflection without having the rule memorized. When you go across the line y equals x, you just swap the coordinates. Right there. They switch places. When you go across the line y equals negative x, you swap the coordinates and both of them become negative. When you go across the y-axis, you change, this is kind of interesting, you change the x coordinate and you make it, if it was negative, you make it be positive. If it was positive, you make it be negative. And when you flip across the x-axis, then you keep them in the same positions, but this time the y is going to be the opposite. So here's our reflection. When you look at a reflection, sometimes you can just tell. You're just like, okay, this looks like it's a mirror image of that. Like it flipped over this line. And sometimes you can't. So a way to tell that it's a reflection, remember, this is the only transformation that has a different orientation. And here's how you tell how that works. You go to a point and you say, okay, B to G. If I'm person B, then G is on my right. But over here, if I'm person B, G is on my left. So that is definitely a reflection. Now we have to figure out the line of symmetry, which you probably can already see. But if you can't already see it, here's a way to find out. We know that the line of reflection is the same distance from the image and the pre-image. So we're going to connect the image and the pre-image and find the middle spot. So I know that the line of reflection is somewhere that hits that dot. Let's do another one. Let's do Z and Z prime. Okay, so it goes diagonally through 4 squares and then 4 more squares. So here's the middle of that dot. If you want to use a ruler, like, be my guest. And then connect all the dots that are the middles, and you'll have the line of reflection. So this is a diagonal that goes up as you read from left to right. So this is going to be over our y equals x. And you can know the rule that you just swap y and x, or you can look at your coordinates. B is 2, -1. B prime is -1, 2. Oh, look, they switched places. Woohoo, got your rule, switch your x and y. On rotations. So this one turns around a central point. And that's usually the origin. It could be somewhere else. We're only doing the origin this year, so don't worry about any of the other points. And here are your rules. For 90 degrees clockwise, you swap x and y and make the x negative. For 90 degrees counterclockwise, swap x and y, make the first coordinate negative in your image. Then 180 degrees about the origin, they don't actually switch, but they do both become negative. And think about it. If you were to do two 90-degree rotations, 90 plus 90 equals 180. So you do your first one, and you swap them and make the second one negative. Then you do your second one, you swap them again, and do the opposite of the second one. Bam, found the rule. So it does make sense, even if it doesn't appear to make sense. Well, only that rotation, it doesn't swap the x and y. But there's a reason for that. They swapped and then they swapped back. All right, now we're going to write a verbal description of this one. I know that this is a rotation because if I look at k's are always in the middle and n's are kind of like this, this still doesn't totally, like, just looking at those 2 points, it could still be a reflection over y equals x. Here's the kicker. Here's the one where I go, oh, yep, that's a rotation, is h. H went all the way around like that. So you can kind of imagine, and you know it's not a reflection because when you look at k, h is on its left on both of them. If it were a reflection, then h would be over here. And you can kind of see that. They would be right across from each other on that line of reflection. So this is a rotation, and it is 180 degrees because it went 2 quadrants. It went 1 quadrant, 2 quadrants. So now we can write our rule. You could just write negative x, negative y, or you could take a coordinate. Let's take h. H goes from -4, 1, to h prime, which is 4, -1. So both of them just changed their sign. So that's how we know that they both have a negative in front of them in the rule. Okay, dilations are an enlargement or reduction, also known as a stretch or shrink of a figure. I love this one because there's only one number in it, and that one number is the scale factor. You don't have to know anything else. And that scale factor has to be on both coordinates in order to be a true dilation. If C, the scale factor, is larger than 1, then the figure gets bigger. If it's smaller than 1, it gets smaller. If it's equal to 1, why even do that? What's the point? It stays exactly the same and it doesn't move at all. Okay, here's our dilation. We're going to identify it. This one's a little tougher, trying to figure out what the scale factor is. So remember, you should always identify what your old shape and your new shape are. Remember, you're going to do old is not primes, right? And then you're going to figure out what you multiplied the old by to get the new. So old times something equals new. To find the something, you divide new divided by old. So I'm going to pick coordinates to figure this out. And let's pick an easy one, shall we? H and G, when you look at the primes, they get gross. They're like in the middle of the square somewhere. Let's pick a pretty point. Let's do our F and F prime. So F prime is at 2, 2. And F is at 4, 4. And when you divide 2 divided by 4, you get 1/2 or 0.5. So 1/2 is our scale factor. We're going to put 1/2 X, 1/2 Y as our rule. Stay tuned for our next video where we figure out how to string these together and how to figure out what happened.